Hi, welcome to the DCI SGO demo. I have a small introduction to Cobalt Strike tutorial sort of embedded within this because it is going to be a sort of basic 101 definition of how Cobalt Strike could be used to attack an ICS. So here's our ICS. It's a Defense Fuel Supply Point HMI, which is a complicated way to say that there's this control panel that has an effect on the cyber physical system. For instance, this LED that's turning on and off is a JavaScript function, and it can take other functions such as showing or hiding this keypad, which actually dispenses the correct amount of fuel depending on how much you punch in. So the attack will be from my laptop to the engineering workstation, which is called GPS IoT, and then it will go send malicious commands to a PLC called SmartBase. So we got a lot of assets that have been connected to the firewall, so I just want to filter by IoT assets that are online. So here is our PLC, one SmartBase. Here is the attacker laptop, which is a GTAC S410 with Ubuntu. That's what I'm recording this on. And then an intrusion detection system called Guardian from Nozomi, which is running on hypervisor on GPS IoT, which is that black box in the upper right hand corner, the Optiplex small form factor computer. That's what's hosting the engineering workstation. So now on to Cobalt Strike. First thing you have to do is start the team server, and that has to be run with admin privileges. So you just start up the team server once you're in the right directory, which I am not. So you set a password. Let's make it GPS3 is the password. It goes and creates a public certificate or a PKI infrastructure so that you could have different clients logging in as different usernames, and then attribute who's who when they're attached to your server. So go back over to the way to run the client, and then it's going to be just like a desktop application with like a point and click menu. GPS3 is the password, connect, and this is the front end. This is the command and control panel for the product. So we're going to click on these headphones, these little listening earmuffs, and we're going to make a listener, and we're going to put the address of the team server, and then change it to the protocol, and then that should be good with the defaults. So that's a listener. Then the attack is accomplished by this PowerShell 1 line, where we will change the port on there as well, and then it's going to give us this string that we'll have to copy and paste. Just like this. So once you have it, you got to get the target to run it. So that can be done by any number of ways. But in the interest of time, I think I'll just run it. without some sort of social engineering campaign, or it was a long process to get the VPN credentials, which we've done in a separate video. And now you don't need admin privileges. It just needs to get through the network. Then you see nothing really spectacular happened over here, but you would obviously want to know what you're running in a PowerShell. So don't do that at home. But for this tutorial, that is what we have done. So as the different target boxes of the campaign call in with their beacon session information periodically, it's going to build this graphical tree here to show your nodes and how they interact. And it's going to get a lot more complex once there's additional VMs and targets and things that can be like a more substantial environment. But in order to escalate and pivot and gain access to that, you got to learn the fundamentals. So out of the box, there's a lot of things you can do here, but if you just put the shell and then a Windows command line command, then it will return that as if you're sitting there. I'm gonna tell the beacon to basically just don't wait, immediately respond and do what the command says to do. Otherwise, it takes a minute or two for each command just to execute, so it's doing its job more covertly. And you can see it's trying to be quiet and wait. So looks like there's some PowerShell scripts here, there's some bash shells, there's some Python scripts, there's a lot of things going on that we would then unpack and download and reverse engineer and see what type of keys or passwords are there if you were to gain access to this very important engineering workstation, mind you. But since we've done our homework, I think we're going to go with a PowerShell-import. Then we'll go get this specially crafted script or malicious script that goes and will cause some havoc within the process environment. So that's loaded into memory, and that's on my computer, not the attacker's computer. I mean, it's on my computer, not the target computer. What is on the target computer is a update script that lets you send API commands to the PLC. So that's how we're going to do things like close the valve and turn the lights on and off. So once the PowerShell import is there with the OT PS1, then you just run it with PowerPick OT PS1. We'll see all sorts of things start to happen now in the process environment, as well as the info that gets enumerated back for us. Well, we got the lights cutting out on the floor, got the emergency ESD light going on and off uncontrollably. Now the pump's on, and you never know what type of catastrophic incident that could cause, depending on the timing of if something's out of service or down for maintenance. Then sometimes a valve opening or a pump turning off could really hurt your infrastructure. So that's the synopsis, and I look forward to unpacking all this stuff and any questions you might have. Thanks.